Welcome back, everyone. First, if the audio and video both are fine, please let me know. Great, wonderful. So let's begin. Now, what we have discussed until now was the first part of our chapter, and this was about space science, where we discussed about various aspects of the universe. We understood what is the universe, the composition, dark energy, dark matter, celestial bodies, and all these things. Now we move towards the second section of our discussion, and this is about space technology. Now, one thing that I should also mention is that whatever we have discussed until now in this chapter was more important for your prelims examination, and now the section that we are entering will be important for both your prelims as well as for your mains examination. So we'll also keep on discussing a few things which remains important from the perspective of the mains exam. Now, when it comes to space technology, this is where we are going to discuss, understand about how do we use space, what is the application of this entire sector, how do we use it to our advantage, and how are we conducting various different uh, you can say experiments or observations and various studies and experiments, etc. So let's begin. And the first part here is to understand how do we even make observations. So there are two ways in which we make observations. Either these are ground based observations or these are space based observations. Ground based and space based. Ground based observations are the observations that we make with the help of telescopes, all right, where we use our telescopes, and with the help of these telescopes we make our observations. So that will be called as ground based observations. So we have optical telescopes, radio telescopes, x-ray telescopes, the infrared telescopes. There are many different types of telescopes. So whenever we are making the use of telescopes to make any observation, we say that these are ground based observations. And then the other way to make the observations is space based observations, where we are making the use of uh, satellites, where we are launching the satellites in one way or the other. That will be called as space based observations. So first, as a part of ground based observations, there are two specific telescopes that become very important, one called as optical telescope and the other one is called as radio telescope. Now first we have an optical telescope. Now optical telescope, you can say, is the most widely used telescope, the most popularly used telescopes. Why? Because it captures the visible part of the electromagnetic spectrum. Now, visible part is the one that we also see. Our eyes can also perceive. So, what we see the world as, how we see the world, the optical telescopes will also see the universe in a very similar manner. So, that's why the kinds of images that you get from optical telescopes is what we can perceive. It's what we can understand. Our eyes can understand. Now, overall, when it comes to optical telescopes, in case of optical telescopes, India has three major optical telescopes, one at Devsthal in Uttarakhand, one in Hanle in Ladakh, and another one in Javdi Hills in Tamil Nadu. Now, out of these three optical telescopes, the most important telescope that India has is the one at Hanle. A lot of important observations that India has made with its optical telescopes, a lot of them have come from the Hanle telescope. Now, this Hanle telescope becomes extremely important because of also its location. Although whether it comes to Devsal, which is near Nainital in Uttarakhand, or Javdi Hills in Tamil Nadu, these are also areas which are in the hilly areas, which are also located in the hills, away from light pollution. But Hanle has a very specific geographical location, which makes it very remote in its nature, and that's why it becomes a better area to keep our telescopes. And that's why Hanle is the place that we chose to keep our telescopes. Now, in case of this particular telescope in Hanle, Hanle also becomes important because it was in the news in last couple of years, because India is also declaring is that it has dark sky reserve. Right, it is being declared as the dark sky reserve. Now, do you know what is the meaning of dark sky reserve? What do we mean by dark sky reserve? And why have we made this announcement that this place has been declared as a dark sky reserve? Any idea about this? Hmm. Yeah, you're correct. So basically, this is an area which is an area which can help in space tourism. That, as Shalu, you have written that you have very clear dark sky, meaning that these are areas where you have very clear night skies, and this is mainly because of absence of any form of light pollution. So dark sky reserve is a place that is related to space observations. Right, where there are very clear night skies, and that's where they actually have been declared as the dark sky reserve. Now just understand this, that there are places in the world, other parts of the world also, where some kind of dark sky reserve has been declared, and this is something that the government of India has declared as the dark sky reserve. Now, Hanle, first and foremost, it is in Ladakh. Now, even in Ladakh, it is in a very remote area. Even if you consider, for example, city Leh, so compared to Leh, it is pretty far away. It is almost 200 kilometers away from Leh, near the China border. There is hardly any transport that goes there. I mean, if you know about this, first and foremost, temperatures are very low because it's a cold desert. Temperature is very low. Hardly any rainfall all throughout the year. So very clear night skies. There is no cloudy weather. More than 300 days of clear night skies is what you observe in Hanle. So more than 300 days of clear night sky, no, very remote location. There is no electricity that has reached there. Almost no water even available, because hardly 2 or 3 days in the entire year it receives rainfall. And away from the city lights, away from any kind of, you can say, any kind of population or any kind of settlement. And because of its remoteness, we do not really see even a lot of tourists going there. All right, it is something, that's why it is something which is also called as astrotourism. It is called as astrotourism, but not a lot of tourists go there, because even if you want to go there, you'll have to find ways to go. For example, let's say from Leh, the city Leh to Hanle, there is only one bus that goes every week, only one bus. So that one bus goes on Saturdays and comes back on Sundays. That's it. Only one bus in a week. So it's not that easy for you to go and come back with in any day that you want. And if you want to take, let's say, a cab, a taxi, and go to Hanle, they would charge you a lot, and you will have to sell some land and then go to these areas. So that's why it becomes very difficult for somebody to even reach these areas, and that's why we see. And because of the remoteness, no electricity, no mobile phone networks, no proper networks, and no internet and nothing. So that's why it's not a place that a lot of people are even interested in going. But if you go, it's a wonderful place to visit. It's a wonderful place, and the kind of views that you will have in the night sky, it's unimaginable. You cannot even think of having such a view from wherever you're living, whether it is metropolitan. If it is, then you hardly see 5 stars in any given night. And even if you live at remote areas, you might see good number of stars, but what you see from these kind of areas is just uncomparable. And this telescope picture that you see right here, this is the Hanle telescope, and this is a picture that I had taken. I had gone to visit this telescope. I had just gone to Hanle. I lived there for a few days and then I came back. So I can give you a first hand idea about the experience there. That the temperature, I mean, this bright sunlight that you see, I had gone in the month of December, and this bright sunlight that you see out here had a temperature of almost minus 10 to minus 12 degrees Celsius. And at night, the temperatures would drop even further. And but the night views were excellent. Even I I went inside this telescope also. They had shown me around inside the telescope, gone and went and saw through it. And there was no water, there was no electricity, no mobile phone networks. So complete peace, in a manner you can say. It was a complete peace. And you also, if you, let's say, are getting distracted and want to study, carry all your notes and just sit there for a couple of weeks. There will be no distraction. Even if you want, there will be no distraction, and you can probably study better and revise and come back. Anyway, but understand the importance of Hanle from this perspective. And that's why uh, dark sky reserves have been declared. Dark sky reserve has been declared in this one place. Now, apart from the optical telescopes, the other ones which are important are radio telescopes. Now, in case of radio telescopes, these are telescopes that would capture the invisible radio waves of the electromagnetic spectrum. They would catch the radio waves. Now, radio waves are longer waves, and these telescopes that will become important because they'll be able to catch these waves which will not be visible to optical telescopes. So that's why they become also useful. And radio waves are also longer waves. And because they are longer waves, they can also travel longer distances. We'll discuss more of it in IT and communication, the characteristics of radio waves. But overall, what we see is that have radio waves are longer, and that's why you can capture objects which are far off at far off distances. So there will be antennas like these, and they basically are the radio telescopes. Now, uh, some of the important radio telescopes that we have in India, one is at Pune and one is at Uti in Tamil Nadu. So this picture that you see right here is of the Pune telescope, the Pune radio telescope. Now, obviously, the kinds of images that radio telescopes will give you are not the images that we are used to seeing. If you look at the comparison here, the first picture that you see here is the picture taken by an optical telescope, and the second picture that you see here is the picture taken by the radio telescope. So that's why you can see the difference between optical and the radio telescopes. So obviously these are just catching all the radio waves that are being emitted by this planet, whereas optical telescopes are taking the photograph of this planet. Now, this is about the ground based observations. Now we come to the space based observations, where to observe something from the space we will have to launch a satellite. Now this is where we need to understand how do we even launch a satellite, what do we do to launch a satellite. Now, for launching a satellite, what do we need? That if you are launching a satellite from the Earth, let's say it has to go to a certain height, and then it has to keep orbiting around the Earth, correct? It has to keep orbiting around the Earth, maybe 1,000 kilometers from the surface. So it has to go to 1,000 kilometers, and it has to keep revolving around the Earth. So in this manner, what happens is that this is where you'll have to ensure that you're launching the object or launching the satellite in a manner that it always remains at this height. Even if it is in its orbit, it is always at fixed at this particular height. Now, to do that, what do we do? How do we ensure that whatever we are launching remains at its height? Now, this is where we bring into consideration Newton's laws of motion. If you remember, there are three laws of motion, right, which talk about the forces and the nature of forces. And here we make the use of first law of motion, Newton's first law of motion. What does Newton's first law of motion say? An object at rest will remain at rest. An object in uniform motion will remain in uniform motion unless acted upon by an external force, right? This is what the first law says, that object at rest will remain at rest unless acted upon by an external force. Now, when it comes to Newton's laws of motion, the first law of motion becomes extremely important in launching a satellite, because first law of motion basically talks about balancing and the unbalancing of the forces. Suppose you have, let's say you have a box kept on a surface, right? You have a box kept on a surface. Now this box will move only when there is an external force, where there is an external force good enough to move the box. When you have an unbalanced force in a certain direction, then only it will move. So for example, let's say 10 newtons of force is required to move this force, move this box. So as soon as you provide that 10 Newton force, then only starts moving, right? Then only it will start moving. So that's why we have to provide this force. And if we want to keep it intact, then we'll have to ensure that you are providing forces from both the ends, right? If you provide the forces from both the ends, equal forces from both the ends, it will not move. So same has to happen in case of launching of a satellite also, that it's all about balancing of the forces, balancing the forces at a certain height, balancing the forces at a certain height. So this is what precisely we have to do when we are trying to balance the forces, all right, wherever we are trying to launch the satellite. So that's why for launching the satellites, at whatever height we have launched the satellite, we'll have to ensure that all the forces on it are balanced. Now what are these forces that have to be balanced? Now there is one natural force which is acting on any satellite. If we have launched a satellite, there is one natural force which is acting on that satellite. Can you tell me what that force is? Which force is acting naturally here? Which is the force that is acting naturally on the satellite? Gravity. Perfect. Gravitational force, right? So on one hand, we have the gravitational force. On one hand, we have the gravitational force acting on this satellite. On the other hand, it has to be balanced. And how do we balance it? How do we balance it? With the help of the motion of the satellite, the force generated by the motion. When you are launching the satellite, you are providing a thrust, you are providing a force while launching the satellite. So that thrust that you are providing, that thrust, the motion of the satellite itself is acting against gravity. So against it, you have the force due to motion acting outward. So one is pulling this satellite towards the earth, and one is keeping the satellite, or trying to force the satellite out of the earth. So that's why these two forces, wherever you are able to balance these two forces, that is where you will be placing your satellite. That will become the orbit of the satellite. So this is where we call these as centripetal and centrifugal forces. Centripetal force and centrifugal force. So the force due to motion which is acting outward is called as centrifugal force, and the force due to gravitation acting inward is called as the centripetal force. So these two forces have to be balanced in any circular motion. These two forces have to be balanced to keep it intact in a given orbit. So this is exactly what we do. So that's why, to keep the satellite in its orbit, the forces acting on the satellite at the required height should be balanced. So this is what we do. We balance the forces and we get to the required orbit. There is this one question that was asked in your paper. Read the question. It is, I would say, slightly difficult question, but read it. I'll explain it. I'm launching the poll for you. Please mark your answers. Hmm. 5% of you have marked A, 21% B, 33% C, and 41% D. The question says the artificial satellite orbiting around the Earth does not fall down. This is so because attraction of the Earth first does not exist at such heights. How is it that even possible? We just discussed that there is the gravitational force that we are trying to balance. So it's impossible that it does not exist at such height. It is neutralized by the attraction of the moon. No, moon is far away. Moon is 384,000 kilometers away from the Earth. One. Second, Moon is very lightweight as compared to the Earth. The gravitational field of the Earth is just one sixth of what the gravitational force of the Earth is. So it's impossible to even think that Moon will be able to balance it out. And did we say that Moon is even involved in balancing these forces? We did not. So there is no question of the Moon. Now comes the real confusion. Provides the necessary speed for its steady motion, provides the necessary acceleration for the motion. Now, option C says provides the necessary speed for its steady motion. Now, there are two problems. One, it is talking about speed. Here, it is not rather speed but velocity that matters. More than speed, what matters is velocity. Can you tell me what is the difference between speed and velocity? What is the difference between speed and velocity? Yes, Himadri, you are correct. Karan, you are correct. Himanshu, no. Shilpa, you are correct. Ramavat, you are correct. Shahid, you are correct. Kirti, you are correct. Good. So, a lot of you have given the correct answer that speed is only about magnitude, whereas velocity has both magnitude and direction. So here it's not only about the speed that you give in the initial phase. It's also about how are you launching, in what direction you are launching, and there is a variability that you have. So that's why it's not even steady motion. It's a variable motion. It keeps on changing. It keeps on changing its direction. So it's not speed and it is not steady, and that's why C is wrong. But I understand that there can be a confusion between C and D because C also talks about speed, and we are essentially providing an initial speed, right? So you might think from that perspective, but just understand what we have to give it is not speed but rather velocity, and that too also not for a steady motion. It's a variable motion, keeps changing all the time. The speeds keep changing, the directions keep changing, and that's why it's not a steady motion. So that's the correct answer will be provides the necessary acceleration for the motion, because we are saying that we have to provide enough thrust or enough force. And what is force? Force is mass into acceleration. Now mass of the satellite or the launcher is fixed, so what matters is how much acceleration is being provided, because you have to act against the acceleration of the earth, right? Acceleration due to gravity of the earth. So you have to act against that, and that's why you have to provide force accordingly. So that's why it's about the necessary acceleration that we provide to this satellite. So that's why I said that it's a bit tough question, but still, if you go by the logic that we discussed in the last slide, it might help you in getting the answer. Now, there are various different types of orbits. You might have heard of geostationary orbit, geosynchronous orbit, sun synchronous orbit, polar orbit, equatorial orbit. There are many orbits to name, but all these orbits can basically be classified into three types of orbits: low Earth orbit, medium Earth orbit, and high Earth orbit. Now try to understand what these three orbits are. First is the low Earth orbit. Low Earth orbit is the orbit that lies between 180 kilometers to up to almost 2000 kilometers. So that will be called as a low Earth orbit. Now why we have chosen 180 kilometers is mainly because at 180 kilometers, we almost say that our Earth is done. I mean, we have uh, escaped the atmosphere of the Earth. So that's why low Earth orbit starts from 180 kilometers, goes up to 2000 kilometers. Most of the satellites, although that we launch in the low Earth orbit, are in the range of 500 to 700 kilometers, but maximum it can be 2000. Medium Earth orbit between 2000 kilometers to up to 35,786 kilometers. And then lastly, the high Earth orbit lies at or above 35,786 kilometers. Now, this is a very specific number, 35,786 kilometers. Now, understand the value of this number, that why is this exact number uh, being used? Because when you are at 35,786 kilometers, this is where the orbit period is of 24 hours, meaning that a satellite which is kept at 35,786 kilometers will complete one revolution around the earth in 24 hours. And what's the significance of 24 hours? It is also the rotational speed or rotational speed of the earth. So that's why if there is any satellite placed at 35,786 kilometers, then in that case, it will take, or it will be completely fixed. It will remain permanently fixed with regards to a point on the earth. Because as the earth rotates, this point also keeps on revolving. So as this always remains intact with regards to a particular point on the earth. So that's the importance. That's the importance of an orbit which is at 35,786 kilometers. So that's why, remember uh, why exactly we are using this exact number. Now, to determine any orbit, there are few factors that determine what kind of orbit it is and where exactly are we placing the satellite. Now, there are three major uh, factors. First factor is height. Now, height as a factor becomes a very, very important factor in determining what kind of orbit we need. Just take this example. Suppose that this is the Earth, all right? Let's say this is the Earth, and then there are 2 points. One point which is located in the low Earth orbit, and another point which is kept in the high Earth orbit. Let's say this is A and this is B, where you have this at low Earth orbit and you have this at high Earth orbit. Now, if I ask you, can you tell me which point is better suited if we want to take pictures and videos of the Earth? Which point is better suited? Is it A or is it B? I'm launching the poll quickly. Please give me the answer. Is A better suited to take pictures and videos of the Earth, or is B better suited to take pictures and videos of the Earth? Hmm. So 46% of you feel it should be A and 54% of you feel it should be B. Can you tell me the reason? Why do you feel it should be A or B? Why do you think A or why do you think B? Hmm. So, Ganesh, you have given the correct answer. Hemlata, Aniket, you have given the correct answer. Ramavat, you have given the correct answer. Kola, you have given the correct answer. Shakti, you have given the correct answer. Wonderful. So, anyone who feels B is the answer, and if you feel B is the answer, why B should be the answer? Hmm. So, see, just understand this, that when you are at A, you are very near the earth. So being near the earth, what means is that you will be able to take very clear pictures of the earth, very clear pictures and videos of the earth. From B, the logic could be that you think that, okay, if I'm at B, I'll be able to cover much of the earth. I will have a wider range to cover. But when you take a picture, do you think of the range that you cover, or do you think of the clarity? Most of the times you'll think of the clarity, that you should be able to get high resolution pictures, you should be able to get very clear crisp pictures, and this is precisely what we also need from the satellites. So that's why uh, we will keep these satellites at A. All right, we will keep these satellites at A. So that's why if we want to take pictures and videos of the earth, we would prefer A over B, because that will give us clarity. Suppose you have launched a satellite which is related to disaster management. So for taking any disaster management mitigation activities, what you would need first is that you should be able to see that area. Now if you are covering that area from B, from high earth orbit, from almost 35,786 kilometers, then you will not be able to take as high resolution pictures and videos that someone, or let's say a satellite placed at just 5 to 700 kilometers, would be able to give you. So that's why we would prefer A over B when it comes to pictures and videos of the earth. Then if I ask you, let's say if I have a satellite meant for communication, where would we keep a communication satellite? Where would we keep a communication satellite? Would we keep it as at A, or would we keep it at B? And also tell me the reason in the comments. What do you feel? That should it be A or should it be B? Yes, Hemlata, Nikhil, you have given the correct answer. Himanshu, you have given the correct answer. Shilpa, you've given the correct answer. Aniket, correct. Karanshu, correct. Lalita, correct. Wonderful. So 62% of you have given the correct answer, that it should be B. Now, why B? The reason is range. That if, let's say, a satellite at A is able to cover this range, then equivalent to this, a satellite at B will be able to cover this much of range. So the range becomes very crucial in placing any communication satellite. That you should be able to cover more area for communication, get wider areas for communication. And because you are using radio waves, they travel very fast. They travel very fast. Radio waves will have the same speed, you can say, more or less as the speed of light, 3 into 10 to the power of 8 meters per second. So that's why they'll travel very fast. So it's not that you'll have a big gap if you are placed at A versus B. Now, can we not place a satellite for communication at A? We can. We can keep a satellite if we want at A, but the problem will be range. So what happens is that instead of using one satellite, you will have to use multiple satellites. You'll have to keep a lot of satellites so that you can increase your coverage area. So that's not cost effective. You're not getting any gains out of keeping it at A. You would rather keep it at B and get a wider range and do it in a cost effective manner. So that's the reason. So that's why communication satellite, we always would prefer B. So A, because we want high resolution. A, because we want high resolution, and here B, because we want wider range. We want wider range, and that's why B will be preferred in case of communication satellites. So that's why this is why we see that height becomes a very important factor in determining what kind of orbit we have and where do we want to keep the satellite. Then eccentricity. Now eccentricity is something that determines the shape of the orbit. Now, shape of the orbit is also very crucial, and we'll discuss that later, that how shape of the orbit also becomes important. Now, eccentricity basically is a value which is denoted by E, which is a value which is between 0 and 1. It can be equal to 0 or more than 0, and it will always be less than 1. So between 0 and 1, you have this eccentricity. All right, this is called as eccentricity. Now, overall, in case of eccentricity, it determines the kind of shape that you have. If let's say the value of E is 0, then the shape is circular. All right. If E is 0, it is perfect circle. As you keep on increasing the value of E, and when it becomes, let's say, 0.999, then it is a highly eccentric orbit. All right. It is a highly eccentric orbit like this. So this, as you can see, that with 0.99, this is what the case is. And with E equal to 0, you have a perfect circle. So how shape matters, we'll discuss that later. Then the third factor is inclination. Now, inclination basically meaning that whether you have a polar orbit or whether you have an equatorial orbit, that will be determined on the basis of the inclination. So inclination from the orbit, whether it is slightly inclined from the equator or is it completely inclined from the equator. So all these things will also matter, and how it matters we'll also discuss that somewhat later. Now, based on these three factors, we understand that there are various different types of orbits. The first orbit is the low Earth orbit. Now, in case of a low Earth orbit, what we see is that these are orbits where there are two types of orbits: polar orbits and sun synchronous orbits. So, first, let's try to understand some of the properties of low Earth orbits. First, the height. Height, as we had discussed, that height is between 180 to up to 2000 kilometers. All right, height between 180 to 2000 kilometers. Then the application of these satellites lie with earth observation. These are also called as earth observation satellites, because as we discussed that we take pictures and videos of the earth from here, so that's why we observe the earth, and that's why it is called as earth observation, or also called as remote sensing. Another term used for it is remote sensing, that remotely we are trying to sense or observe the earth. So height, application, then the launch vehicle that we use, or the launcher that we use here, are called as PSLVs, and we'll discuss about what PSLVs are. You might have heard of PSLVs. So PSLV is Polar Satellite Launch Vehicle. So this is a launch vehicle that is used to launch a satellite in the low Earth orbit. So launcher is PSLV. We'll discuss PSLV later. Then these are lightweight satellites. These are not heavy satellites. The satellites that are launched here, they will be lesser than 1500 kg in most of the cases. They will be less than 1500 kg. So that's why these are lightweight satellites. And then in case of the low Earth orbit, one thing also worth noting is their period of rotation, period of revolution, their orbit period. Their orbit period is of 1.5 to 2 hours. Orbit period is of 1.5 to 2 hours, meaning that they complete one entire revolution in 1.5 to 2 hours. So that is what we mean by orbit period. And then lastly, one more point which is important is their life cycle. Their life cycle generally is of 3 to 5 years. So they would only be functional for 3 to 5 years, and after that they would have to be replaced. And because they are in the low Earth orbit, they are very near the Earth. That's why it makes it even more difficult for them to exist here for longer. All right, because there will be a lot of gravitational pull, so you always have to keep maintaining that orbit. Extra fuel is used to maintain that orbit. So that's why it's not that easy to make it uh, be here, survive here for a longer duration. So that's what low Earth orbits are. Now, there are two types of low Earth orbit. You have polar orbits and sun synchronous orbits. Now, sun synchronous orbits, we say that these are special case. This can be said to be a special case of polar orbits. So these are not different from polar orbits, these are special cases of polar orbits. And these are orbits where we say that orbits are synchronized with the local solar time of a place. Local solar time of a place. Now, what do we mean by synchronizing with the local solar time? These are orbits which will come back to exact same position one day later, meaning that suppose that they are overhead Delhi at 10 a.m. in the morning, so only 24 hours later they come back overhead Delhi at 10 a.m. So every day they will be overhead Delhi at 10 a.m. and this will repeat for a long time. That's why we are saying that it is synchronized with the local solar time of a place. Now, you might also think that we are on one hand saying that orbit period is of just 1.5 hours, that it is completing one revolution in 1.5 hours. Then how is it possible that it is coming overhead only 24 hours later? Should it not have come back overhead 1.5 hours later? Can you tell me what the reason is? That why is it coming overhead only 24 hours later? Can you think of a reason? Yeah, Srijit, you have given the correct answer. Lalita, you have given the correct answer. Shalu, you have given the correct answer. Himanshu, you have given the correct answer. Ganesh, you have given the correct answer. Somewhat correct. You are not completely correct, although. So, understand what's happening. It completes one revolution in 1.5 hours, but the Earth is also rotating. So, by the time it completes one revolution, the Earth would have rotated. And if it comes back, although it comes back to the same latitude, sorry, because although it has come back to the same latitude, it has not come back to the same location, not the same longitude, because the Earth has also rotated. So it comes back in 1.5 hours, but by the time the Earth has rotated, so it will be synchronized in a manner that it keeps on completing all its revolution and comes exactly back at the same time the next day in the morning, or next day, whatever be the stipulated time. So that's why these are called as sun synchronous orbits, because you have synchronized the time with the local solar time of a place, and hence the name sun synchronous. That's why the name sun synchronous. Now, overall, these orbits, usually you will see that whenever satellites are launched in the polar orbit, they are normally launched in the sun synchronous orbit. That's why sometimes in the newspaper you will see that they use the term SSPO, sun synchronous polar orbit. Whenever the launches are done, you'll find that they'll use the term SSPO because it's a polar orbit, just that it has been synchronized with the local solar time of a place. So that's why these are the kinds of orbits that are located in the low Earth orbit, and predominantly these are what? These are polar orbits. Now, there are various applications of Earth observation, or what we call as remote sensing. So in this case, and these are all the applications and the list of applications I've taken from ISRO website. So on the website of ISRO, these are the applications that have been listed. That these are the applications for Earth observation satellite, because these are where you need to observe the Earth closely, where you need to understand, need to take pictures and videos of the Earth closely. So that's why all these have been listed as Earth observation applications of these satellites, or especially of this orbit. Now, all there are multiple satellites that we have launched to the low Earth orbit. For example, we have Cartosat, OceanSat, ResourceSat, MineralSat, ReSat. There are n number of these satellites that we have launched over the years, and all of these are called as Earth observation satellites. So nomenclature goes like this: that you name it with the help of its application and add sat to it. So that is how the Earth observation satellites are named. Most of the times, this is how they are named. So Earth observation satellites will be useful in this particular way. After this, we have the medium Earth orbit. But before going there, if you have any doubts, if you want to ask anything, please let me know. If you have any questions for me, polar orbits. So see, in case of polar orbits, what we are saying is that it is flying over the poles of the earth. That's why the name polar. It is synchronized with the poles of the earth. That's why the name polar orbit has been given. And when it comes to the low earth orbit, it's easier for us to have polar orbits than equatorial orbits. Polar orbits work better in the low earth orbit. So that's why you'll see that most of these orbits are polar in nature when it comes to a low earth orbit. up up to at what height the earth's gravity is applied. Now in a manner you can say that the earth's gravity would apply for a very long distance, because gravitation is a force that it is not which is not zero even at infinity. It will just keep on decreasing. Influence wise, it will just keep on decreasing, but up to very easily up to 4 lakh 5 lakh kilometers above the surface of the earth, the influence of the gravitational pull of the earth can be very easily felt. Not only there, I mean, up to, even if you have smaller objects, it can go up to 10 lakh or even 15 lakh kilometers beyond the surface of the earth. Eccentricity. Eccentricity basically is a value that we determine on the basis of the axis that you have for any given shape. So that will determine the eccentricity, and this eccentricity value for various different types of shapes are different. So for example, for ellipses it is different, for parabola it is different, for hyperbola it is different. For every shape they will be different based on their axis. So we will be calculating it on the basis of that. But long story short, it just helps you in determining the shape of any given particular curved surface. What is the purpose of cartosat? So comes from cartography, and cartography is related to the study of maps. So in case of Cartosat series satellites, it helps us in especially helps us in determining the boundaries in defense related operations, and even in agriculture we make the use of Cartosat series satellites. Can we have polar orbits at HEO? Theoretically, yes, but practically, no. We don't make any orbit in the polar areas in the high Earth orbit. The basic idea behind why we don't do that is because most of the times we are using the high Earth orbits for communication purposes. And if you are at polar regions, then lesser countries are there in the polar areas and more countries are there in the equatorial areas. So covering the equatorial areas is better as compared to covering the polar areas. And also because of the way the bulge of the earth is, it's better to keep a satellite in the equatorial orbit for longevity in the high Earth orbit. So theoretically it is possible, but practically we don't place polar orbits in the high Earth orbit. How water and food available for you? Acha, in Hanle. So uh, there there were homestays, a couple of homestays that were available. Uh, they have, I mean, a lot of reserves that they keep, and they would use that. And at the same time, water comes by heating a lot of ice, and that is where they get their water from. Solar energy becomes a big source for them in these kind of areas. Uh, so water and food was available. It's, I mean, just that in a very limited way, because otherwise there are no sources of running water, etc. there. right? So let's move to the next topic, and our next topic is medium Earth orbit. Now, for medium Earth orbit, we had discussed that medium Earth orbits start from 2000 kilometers and they go up to 35,786 kilometers. Now, in case of the low Earth orbits, just understand what's happening in case of low Earth orbit, because sorry, in case of medium Earth orbit, because medium Earth orbit comes beyond 2000 kilometers. So largely for Earth observation, it will not be useful, right? For Earth observation, it will not be useful. It will be useful for other, it will be useful in other ways, and especially when it comes to uh, medium Earth orbit, they are precisely more important from navigation purposes. Example, GPS. You might have heard of GPS. That GPS is used by our mobile phones, like let's say if you're using Google Maps. So in Google Maps, we are making the use of GPS, and with the help of GPS, we are able to locate a place and we are able to use the directions, etc. So navigation satellites are largely, you will see most of the navigation satellites of the world, they are placed in the medium Earth orbit, and especially there is this medium Earth orbit called as the semi-synchronous orbit. Now, semi-synchronous orbit especially is important from the perspective of GPS. So semi-synchronous orbit is used by GPS, and it is located at 20,200 kilometers above the surface of the Earth. 20,200 kilometers, and this is mainly because it completes one revolution in 12 hours. So it has an orbit period of 12 hours, and this is basically used by GPS. So semi-synchronous, the name semi-synchronous has been given because it completes one revolution in 12 hours, that is two revolutions in a day. So that's why the name semi-synchronous has been given to this orbit. The second orbit that we have in the medium Earth orbit is a Molniya orbit. Now, in case of Molniya orbits are orbits, and this is a precise orbit which was designed by Russia. This orbit was designed, or in a manner you can even say that it was invented by Russia. It was designed or invented by Russia, and this orbit has been designed to take care of the communication needs. And hence, this is where Russia would launch its communication satellites. This is where Russia would launch its communication satellites, and this, for this precise purpose, this Molniya orbit was designed by Russia. Now, this orbit that you see right here in the picture, this is the Molniya orbit. All right, this is the Molniya orbit. Now, as you can see that this is a highly eccentric orbit. It's a highly eccentric orbit. Now, what happens is that when you have very highly eccentric orbit, and when the Earth is placed at one part or one corner of this orbit, any satellite which is there in this orbit, just remember this, that this is also something that we know in case of gravitation, that when you are near the central object, if let's say there is any revolution happening, so when that object comes near the central object, it moves faster, and when it goes away, it moves slower. So even on the Earth also it applies, that when Earth is revolving around the sun, the movement will be faster when it is near sun, and movement will be slower when it is away from the sun. So same goes for any satellite also being launched here, that the satellites will move faster when they are near the Earth, and they will move slower when they go away from the Earth. So in this manner, what we see is that they would be spending a lot more time in the northern hemisphere than the time that they spent in southern hemisphere. So from southern hemisphere, they would move quickly, and they would spend a lot of time in the northern hemisphere. And this is precisely required because Russia has not created this orbit for Australia, it has created it for Russia. And why did Russia need to create this? Because normally all the communication satellites, normally all the communication satellites are placed at the equator, right? They will be placed in the low Earth orbit at the equator. So now what happens is that the range that they might be able to cover from here could be this much. All right, let's say it is able to cover this much area. Now we know that a large part of the landmass of Russia lies in the Arctic areas, lies near the poles. So it's when it comes to an equatorial orbit, it is not as useful for Russia as a polar orbit would be. So that's why they have created this kind of a Molniya orbit so that they can cater to the communication needs of Russia. So that's why they designed this Molniya orbit. Now this is the Russian side of the story. There is the US side of the story also, because these all these designs etc happened at a time of Cold War, and during Cold War whatever Russia would say US would not believe it, whatever US would say Russia would not believe it. So when Russia said that okay, we have a new orbit and we had to bring this orbit because uh, equatorial orbits are not able to cater to our communication needs, so hence we have created this orbit. Sorry. US said that that's not the case. Russia has created this orbit because they wanted to spy on us. And it's a new orbit, so nobody would know even if they are spying on us. So they would happily keep all their spy satellites in the Volney orbit and spy over the US. This was the US side of the story. So that's why at this point of time, there were a lot of stories like this, that one side will say something, the other side will say something completely opposite of it. But the official reason that Russia had explained was this, that this is why Molniya orbit is needed. That's why here the shape plays a major role. That if it was a normal circular orbit, then it would have uh, spent equal times in the northern and the southern hemisphere. But that's not what Russia needs. It needs it to be placed largely in the north hemisphere and less in the southern hemisphere. And that's why this kind of a shape was designed for this orbit. Now, in case of medium Earth orbit, uh, what we know is that largely medium Earth orbits are used for navigation purposes. Now, especially when it comes to navigation, if we talk about the Indian navigation systems are a bit different. In Indian navigation systems, we have been using a mix of medium Earth orbit and high Earth orbit. Medium and high Earth orbit. So we have two navigation systems, one called as Gagan, second one called as Navig. Now, Gagan is a mix of medium Earth orbit and high Earth orbit. It uses the GPS satellites and it uses the GSAT satellites. GSAT belongs to India. And Navik is completely based in the high Earth orbit. It is based in the high Earth orbit where you have all the IRNSS satellites. So that's why Indian navigation has two different systems. The first one is Gagan. Gagan stands for GPS aided geo augmented navigation. That's why GAGAN Gagan. Now Gagan system, the Gagan architecture, as I told you, is a mixture of GPS satellites and geostationary satellites, basically the GSAT satellites. So a set of these two satellite systems are being used to help in civil aviation in the country. All right, so Gagan system is something that is helping the civil aviation in the country, and jointly it has been prepared by ISRO and Airports Authority of India. So ISRO and Airports Authority of India, they have come together, collaborated, and created this Gagan architecture to largely help in civil aviation. Now, how is it going to help in civil aviation? The basic idea of the Gagan system is to reduce the total flight time, reduce flight path and time. So it will be able to reduce the total flight path. Now, what happens is that when you, let's say, are going from one place to another, suppose from Bangalore somebody is going to Kolkata, so it's not that you'll be taking a straight line path. What happens is that you take a path maybe something like this. So the actual path is much longer than the straight line distance between these two places. So what we want to do with the help of Gagan architecture is reduce this total flight path, reduce this total flight path length, and hence also decrease the total time that the flight is taking. And this is also something that will help in fuel saving, right? It will help in fuel saving as well, because now flight path is shorter, so less fuel is being used. So that becomes very very crucial in that perspective. So it also, that's why, helps in saving cost. It helps in saving cost also. So that's why civil aviation, it helps in three ways. The main thing is that it is trying to reduce the flight path and hence save fuel and hence also save cost. So that's why we uh, understand that this is how the Gagan system is used. So it is GPS aided geo augmented navigation implemented by Indian Space Research Organization, that is ISRO, and Airports Authority of India. These two have come together and they have created the Gagan architecture. Now, when it comes to the Gagan architecture, although it, most importantly, it is about civil aviation, but at the same time, there are other ways in which it can be used. For example, in transportation, maritime, highways, railways, surveying, in all these ways, we'll see that there can be one way or the other in which the Gagan system will be able to help. Apart from the Gagan system, the second system is IRNSS, that is Indian Regional Navigation Satellite System, also called as NAVIC. Also called as NAVIC, or Navigation through Indian Constellation of Satellites. So that's why the name NAVIC. Now, in this particular scenario, when it comes to IRNSS or NAVIC, this is where we see that this is our Indian navigation system, and kind of you can say it's the replacement of GPS. We are trying to replace the GPS system with the help of IRNSS system. Now the question is, why are we trying to replace the system? Why do we want to replace the uh, uh, GPS system with IRNSS system? The reason why is, first of all, obviously GPS belongs to the US. It is maintained by the US Air Force. So obviously when you are allowing US or the US Air Force to get all the data or function in India, they are getting all the navigation information of the country, which is not good for the security of the country. It's not that we have bad relations with the US, but you do not know in what sense that data can be used in the future. So from security perspective, we understand that it's better to be self-reliant, better to have a domestic system rather than relying on a navigation system like GPS. And then you can say it's also some learnings from the past, of what we have seen in the past, and especially two important years, 1998 and 1999. In 1998, you might know that we had done a nuclear test. We did a nuclear weapon test. Now, we obviously did not tell anyone about this nuclear test, and nobody was aware that India was ready with a new nuclear weapon. Because if, let's say, internationally it was known, then everybody would put as much pressure as possible to ensure that India does not go ahead with this nuclear test. So that's why we did not tell anyone and we did this test. Now, US had some information. They somehow had come to know that there is something that India is planning of this sort. So then they were spying on India with the help of the same GPS satellites. The same GPS satellites were being used, some of the other satellites were being used to spy on India and to see whether India actually is working on such systems or not. So thankfully for us, they could not find it, and we did a successful nuclear test back in 1998. And then the next year, 1999, the time of Kargil War. At the time of Kargil War, again, we see something similar. that now what happens is that India asks for US help. You might know that the Kargil and the Dras sectors is where Pakistan, from the Pakistan occupied Kashmir side, had started entering the Indian administered borders. So as soon as they started coming in, we came to know about it. We launched an attack against it, and we were able to send them back away from the line of control. Now, at this point of time, we asked for US help. We asked for GPS information because we needed that information to fight the war, because we were at a disadvantage. You might know about this, that the Pakistanis, they were sitting on the top of the hills, and we were trying to climb above, which was extremely difficult task. Still we were able to do it, and we were able to defeat them. But we wanted and we asked for GPS information from the US at this point of time denied the information. This is what US always has been. Every time when they have to pick something between right and wrong, they would pick whatever suits them. So it's not about right and wrong. So in Asia, you can say in South Asia, they always have wanted to balance out the power of India in one way or the other. One reason behind China also becoming such a big power is the US, because initially they used to support China a lot because they thought that China would act against Russia and India. But then China also developed as a big power, and now they're against the US. Same they did with Pakistan. They used to keep on supporting Pakistan on everything, even knowing that Pakistan is wrong in most of the accounts. But they still kept doing it all the time. And this is where we have seen that US always, although I mean we have good trade relationships, good economic relationships, fine enough political relations, but at the time of need, US has never been helpful. And this again happened in 1999 when we asked for information from them. And this is where you can say was the point of realization for us, that we need to have our own navigation systems. We cannot rely on these navigation systems. And then in 2001, the program was established. The program started 2003 onwards. We started building these satellites, and 2013 is when the IRNSS program was completed, and then we launched a set of 7 satellites. Right, we launched a set of 7 satellites, and where you have 3 geostationary and 4 geosynchronous satellites. Now what we mean by geostationary and geosynchronous, we'll just read in some time. So just for now, just know this, that there are 3 geostationary satellites. This is one, this is two, and this is three. So these three are geostationary satellites, and there are 4 geosynchronous satellites. So this is one, this is two, this is three, and this is four. So 4 geosynchronous satellites and 3 geostationary satellites, orbiting at an altitude of almost 36,000 kilometers, to be precise 35,786 kilometers, covering India and up to 1500 kilometers beyond its borders. Now, when it comes to IRNSS, it becomes very crucial because now it is something that will provide positioning, navigation, and timing services to India as well as the region, covering up to 1500 kilometers beyond the Indian boundaries. Now remember, this is Indian Regional Navigation Satellite System. GPS is Global Positioning Service, meaning that GPS covers the entire Earth. It is a set of 32 satellites in total. It covers the entire Earth. Whereas in case of IRNSS, it only covers the Indian region. So India plus the Indian Ocean region is what it covers. So that's why it is not bothered about the global coverage or covering the entire Earth. It's an Indian regional navigation satellite system. So that's why India plus up to 1500 kilometers beyond Indian borders is what IR and SS satellites cover. Now, as a part of this satellite, there are satellite system. There are 2 services that we get. One called as standard positioning service, and the second one is called as restricted service. Standard positioning service and restricted service. Standard positioning service is something that is related to the normal day-to-day activities. The basic usage of, let's say, something like a Google Maps is standard positioning service. Restricted service is something which is also called as precision positioning service. Precision precision positioning service. All right, it is also called as precision positioning service, and it is something uh, which is supposed to be given only to the people who are authorized to use it, only to the people who are authorized to use these services. Otherwise, others are not going to get any access to these services. For example, areas which are sensitive for India, areas where we have kept our missiles, we have kept our uh, let's say satellites and all the defense related areas which are sensitive. In all these areas, the access will be restricted only to the people who are authorized to access these areas. So this is precisely what we do, and that's why there are these two services. So that's why from security perspective also it becomes better because of the presence of these systems. The accuracy is supposed to be better than 20 meters in the primary service area. Now we have been trying to increase this accuracy even more, and we have been able to reach up to 10 meters of accuracy, meaning that if it is showing a place, it is in the radius of 10 meters from that place, which is a very good accuracy to have. Although GPS has a higher accuracy, GPS has an accuracy of 5 meters, but even 10 meters or even 20 meters for that matter is a very good accuracy to have. All right, so this is what we see about IRNSS. The other uh, system in navigation is the global positioning system, that is GPS. Now, in case of GPS, there are 32 satellites in total. We discussed that it is placed at 20,200 kilometers above the Earth. Now, with regards to the GPS system or any navigation system for that matter, there is one very important concept which is called as triangulation. Now, what GPS does, or what even IRNSS does, or any other navigation system does, is that they would use something called as triangulation. Now, triangulation is where instead of using one satellite, we use a set of three satellites. All right, we make the use of a set of three satellites together. So, we are using a set of three satellites to determine the position of a place, and this helps us in increasing the accuracy. This will increase the accuracy for us. So as you can see that if you have these three covering the entire area, this is where they will become very precise in the primary coverage area. So this is how we see that the GPS system works. And not only GPS systems, but even any other navigation system will uh, use this method that is called as triangulation. Sometimes even more satellites are used. For example, GPS uses a fourth satellite also, so that they can increase the accuracy even further. Read this question. This was asked from in your paper in 2018. It's a very simple question. I'm launching the poll for you. Please mark your answers. Hmm. So as I can see, 70% of you have marked A, which is the correct answer. Wonderful. Question says, with reference to the Indian Regional Navigation Satellite System, consider the following statements. First statement says IRNSS has three satellites in geostationary and four satellites in geosynchronous orbits. This is correct. We discussed about this, that three geostationary plus four geosynchronous is the configuration. Second says IRNSS covers entire India and above 5,500 kilometers square kilometers beyond Indian borders. This is wrong. We discussed that it is up to 1,500 kilometers beyond the Indian borders. So that's why second statement is wrong. The third statement says India will have its own navigation system with full global coverage by the middle of 2019. Now, middle of 2019 is already gone, and we don't have a full global coverage. And anyway, we are not concerned with full global coverage. It's not about full global coverage at all. It is Indian Regional Navigation Satellite System, only covering India and up to 1,500 kilometers beyond Indian borders. So that's why correct answer will be only one. That is A. The next is high Earth orbits. But let's take a small break and let's come back on the other side with high Earth orbit. But meanwhile, if you have any questions, please post your questions. After the break, I'll take your questions first and then we shall move ahead with the discussion on high Earth orbits. Or if you want, you can ask your questions first and let's take a break after that. Repeat why 35,786. So at 35, we are just about to discuss that again in high Earth orbit. But at 35,786 kilometers, the orbit period is of 24 hours, meaning that the satellite will complete one revolution in 24 hours, and the Earth also rotates in 24 hours. So what happens then is that this point or this satellite is going to move with the rotation of the Earth. So what happens is that it always remains permanently fixed with regards to a point on the Earth, and that becomes especially important in communication. We'll discuss how. We'll discuss that in high Earth orbit. Once again, polar synchronized satellite features. I don't understand your question. Question I sent on mail with answers. Have you sent a mail to me? Is what you're saying? What drives the planets to revolve around the sun and not just collide on it? Basically, the entire solar system as it has been formed, it's mainly because of the conservation of angular momentum. And this conservation of angular momentum, it just keeps it in its orbit, and hence they are exactly located at a place from where they can keep on revolving around the sun. Please explain forces that make objects to stay in orbit. Two forces. One, there is a force that is gravitation, which is pulling the satellite towards itself, towards the Earth. Then, to counter that gravitational force, we are providing the thrust. We are providing the initial force, and that force that we provide, that is balancing out the motion that the satellite takes. That balances out the effect of gravitation. So these are the two forces. One, gravitation, which acts naturally, and second is the force, the thrust that we provide while launching the satellite, and this motion. So that's why these are the two forces that act against each other. And why polar satellites? So polar satellites, basically, we discussed that polar satellites will be placed near the Earth. They will be used for Earth observation, and they would complete one revolution within 1.5 to maximum of 2 hours. So that is what we discussed about the polar orbits. Why don't they collide due to gravity? They would not collide because of angular momentum. Because of the momentum that they have gained, they will keep on living in this. Just imagine, let's say, you taking a stone. All right, you take a stone and you wind it with a thread, and then you keep on whirling it. Then what happens? As long as you are able to provide this force, it will keep on revolving like this, right? So that is what happens, that it has gained this motion. So unless there is a change, unless you, let's say, either decrease the force or you increase the force, it will remain in its orbit. So same is happening with all the planets which are revolving around the sun. Why satellites are launched from equator? We'll discuss this. This is a part of our slides, not today rather, but in the next class, but we'll discuss that in detail. Is Molny orbit restricted to Russian space agency? Yes, Russia primarily uses it, and if somebody has to use it, they have to take permission from Russia. All right, any other question, anyone? If satellite dies, then will it fall on the earth as no rotation happens? There are two possibilities. Either it can fall on the earth, and many a times when we program a satellite, we program it in a manner that when they are not operational anymore, they should fall in the Pacific. So we program it in a manner that they fall into the Pacific. Or there are chances that they might fly away also. But we try to restrict it in a manner that they fall back into the Pacific. PSLV is also used for MEO. Can be used. When can it be used? We'll discuss that when we discuss PSLVs. We'll discuss that. How to provide threshold force for satellites? We calculate it. It's exactly a calculation based thrust. So how much thrust will be provided? It's completely based on the calculations of where we are sending the satellite. Why satellites launch from equator? I just told you that we'll discuss that in detail. In the next class, we'll discuss this in detail. It's a part of our discussion. It's a part of the slides in the next class. Anyway, so let's take a small break here. It's 6:55, so let's be back by 7:05, and we shall have a discussion on the high Earth orbits. Welcome back, everyone. Next topic for us is high Earth orbit. Now, high Earth orbit, we discussed about the high Earth orbit, that the height that at which the high Earth orbit is located at 35,786 kilometers. Correct? Now, application wise, this is where we are launching the satellites meant for communication, any kind of communication, whether it is television, radio, mobile phone, telephone, telemedicine, teleeducation. There are so many ways in which one way or two-way communications can work, and for all that we are launching the satellites at high earth orbit. So application wise, this is what the application is. Then the launcher that is useful here, the launch vehicle that we use here, is GSLV. And we'll discuss about GSLVs and PSLVs probably in the next class. So GSLVs will be used here. Then these satellites, these are heavy satellites. These are heavy satellites. So normally they would be more than 2000 kg. They will be launched mostly more than 2000 kg. Then these orbits, when it comes to these orbits, the orbit period, as we discussed, that when you are at 35,786, the orbit period will be of 24 hours, meaning one revolution completed in 24 hours. And the life cycle of satellites placed in the high earth orbit, life cycle of satellites can easily be 15 to up to even 20 years of time. Now this is also which is very important thing, because if suppose a communication satellite is being placed in the low earth orbit, then in that case they'll first of all you'll need more number of satellites, and also they'll be only operation for like 3 years or 4 years, and these satellites, they are operation for like 15 years of time. So that's why you save a lot of time and effort when you keep a satellite in the high earth orbit versus when you keep a satellite in the low earth orbit. So that's why we'll prefer high earth orbit for communication needs. Now when it comes to the high earth orbits, again there are two types of orbits that we have. One called as geosynchronous orbits, represented as GSO, and then you have geostationary earth orbits called as GEO. And again, in this particular scenario, this you can say that it is a special case of geosynchronous orbits. Geostationary earth orbits are special case of geosynchronous orbits. Now why are we calling it as a special case? Understand the basic differences between geostationary and the geosynchronous orbits. In case of these two orbits, let's figure out those three factors that we had discussed. The first factor for determining an orbit was height. Now height, where it all these satellites are kept, for both are the same, 35,786 kilometers. So this does not change. This does not change. So this remains the same for both. All right. Now the second factor that we had discussed was eccentricity, or the shape of the orbit. Now shape of the orbit in case of geosynchronous is elliptical. These are elliptical orbits, whereas in case of geostationary orbits, these are circular orbits. Right? These are circular orbits. So this is what we see as a difference between the two. So one is 30, the height is the same for both, but shape is different. Where geostationary earth orbits are exactly circular in nature, whereas geosynchronous orbits can be elliptical in their shape. The third factor, if you remember, we had discussed was inclination. Now, inclination wise, when it comes to geosynchronous satellites, they can have small inclination from the equator. Whereas when it comes to the geostationary orbits, in case of geostationary orbits, we see that they have 0 degree inclination. 0 degree inclination. Now understand what happens because of that. In case of geostationary Earth orbit, height is fixed. In a manner, you can say that the radius is fixed. Shape is also fixed, that it is circular, and it does not even have any inclination. So because of all these factors, this becomes a unique orbit. This becomes a unique orbit, that there is only one such orbit, which is called as the geostationary Earth orbit. Whereas in case of geosynchronous orbits, there are multiple orbits possible. Because first, elliptical, meaning that there is a variation in the shape. There are various different types of elliptical, right? It can be highly eccentric elliptical, it can be kind of a circular elliptical. So that's why shape can vary, and at the same time inclination can also vary. It can have a 2 degrees inclination, 5 degrees inclination, 10 degrees inclination. So that's why there are multiple orbits which are possible. So here you have multiple orbits possible. There are multiple orbits possible in case of geosynchronous orbits. So this is why we are saying that geostationary orbits are special case of geosynchronous orbits, because all these three parameters are fixed. Height is fixed, inclination is fixed, and the shape is fixed. So if you look at this orbit, this is what the basic difference is, that geostationary orbits lie on the plane of the equator. They have a 0 degree inclination with the equator, so they lie on the plane of the equator, whereas geosynchronous orbits can have a little variation. So that's why understand the term geostationary Earth orbit. Why the term geostationary? Because it is stationary with regards to a point on the Earth. Why we say that it is geostationary? Geo we use in terms of the Earth. The term geo, when you study geography, you are studying about the Earth. That's why GEO is used there. So here also we are saying it is stationary with regards to a point on the Earth. So it is, the term is used because it is stationary with respect to a point on the Earth. So it will just look like a star. It will just look like a star in the night sky when you watch a satellite in the geostationary Earth orbit. So when it comes to the use of geosynchronous orbits, it can be used largely for satellite communication. So telecommunication, telemedicine, teleeducation, television, mobile communication, radio, internet, in all these ways of communication, we can make the use of these satellites. There are two satellite systems that we have used in India, one called as the INSAT series satellites and the other one called as the GSAT series satellites. Now, there is no difference between these two satellite systems, just that initially we did not have our own launch vehicle, and this is when we were relying on other launch vehicles or the launch vehicles by some of the other countries like France, like Russia. So then we used to name it as INSAT, and then we started using our own launch vehicles like the GSLVs, then we renamed it as GSAT. So otherwise, there is no difference between INSAT and GSAT series satellites. Read this question. This was asked in your paper. I'm launching the poll for you. Again, I would say it's an easy question based on what we have discussed. Please mark your answers. Hmm. So 70% of you have marked A, which is the correct answer. Let me just discuss this with you. Satellite used for telecommunication relay are kept in a geostationary orbit. A satellite is said to be in such an orbit when first, it is the orbit is geosynchronous. This is correct. We discussed that geostationary orbit is a special case of geosynchronous orbits. So this is correct. The orbit is circular. We discussed that the shape is circular for geostationary. Orbit lies in the plane of the equator. This is also correct. We discussed that it has a 0 degree inclination. So hence you can say that it lies in the plane of the equator. So this is also correct. Fourth says the orbit is at an altitude of 22,236 kilometers. Is this correct? This cannot be correct. I have been telling you 35,786 kilometers. The number of times that I have uttered these words, 35,786, that you should, even in your sleep when you are dreaming, you should be dreaming of 35,786. So that's why correct answer is 1, 2, and 3, not 4. 4 is wrong. Now, there are some of the other satellites also. So, what we have discussed are all the application based satellites with regards to Earth observation, navigation, and communication. Beyond that, there are certain other satellites, for example, the satellites that are meant for space science. Mangalyaan, Chandrayaan 1, 2, and 3, Astrosat mission, Aditya L1 mission, the upcoming Gaganyaan mission. So, all these are missions, all these are programs which are related to space science. So, these kind of satellites will be called as space science satellites. Then we have experimental satellites. These satellites are useful when we want to conduct certain experiments, whether it is atmospheric or agricultural related experiments, defense related experiments, space program based experiments, testing out a component that we are about to launch. So there are multiple different things for which these experimental satellites can be used. So that's why these are called as INS. Examples are INS. INS stands for ISRO Nano Satellite. ISRO Nano Satellite. That's why INS. So example of experimental satellites. Then a very important bracket of satellites is small satellites. Now, in terms of small satellites, these are satellites which are less than 500 kg class satellites. All right, these are less than 500 kg class satellites. Now, this we divide into various brackets. We have mini satellites, we have micro satellites, we have nano satellites, we have pico satellites. Now we even have femto satellites, but that's not important. So mini satellites are in the range of 100 to 500 kg. Micro satellites usually in the range of 20 to 100 kg. Nano satellites usually in the range of 1 to 20 kg, and pico satellites are less than 1 kg. So this is how we define the various different classes of small satellites. Now, among all these small satellites, the most important one I would say are the nano satellites. And today we see that there is a very rapid growth in the market of nano satellites. Very quickly, the number of nano satellite market is extending in India, across the world. Number of satellites that we have launched, the number of nano satellites that we have launched over the last 1 decade is extremely high as compared to whatever launches we have done before that. So, for example, up to 2014, only 75 nanosatellites were launched by the entire world ever. And since then, I would say the numbers are in thousands. So, just imagine the difference, 75 versus thousands. So nanosatellite market has been growing. Understand why, and also from the perspective of your mains examination, why do you feel that nanosatellite market is growing? Or even think of this as a question which talks to you about, asks you about applications of nanosatellites. Let me take this as a discussion with you. You tell me the points, I'll write the points. If you miss any point, I'll write those points. Okay, cheap is one correct answer. So you can say that it is cost effective. What else? Less fuel and time. That's also correct. Less fuel, less time. This is also correct. Easy to launch. Yes, we can say that it is easy to launch. What else? Low maintenance. That is also correct. Low maintenance, also we can say that. Low maintenance. What else? It can be used in research and development. So in a manner, you can say that it can be used as experimental satellites. Better to say that it can be used as experimental satellites. So this is also a valid point. Long lasting, no, I wouldn't say that these are long lasting. Usually they will be useful for very short period of time. So we can't say that. Manufacturing done in less time, yes we can, but already we discussed this. Less time, let me clarify this, to manufacture. Only for specific purposes, yes we can make specific purpose satellites. So these are all good points. Yes, one very very important point that was missing until now is revenue. When you look at from India's perspective, India has been generating a lot of revenue through nano satellites. So what we have seen is that it has become a big source of revenue generation for India. It has become a big source of revenue generation for India. Now how? The early example you can take is of PSLV C34. Now, in case of PSLV C34, we launched 104 satellites in one single launch. 104 satellites. Now, out of these 104 satellites, 103 satellites were nano satellites. There was only one bulky satellite, which was a Cartosat series satellite, and apart from that, all the other satellites were nano satellites. And also imagine this, that out of all these 104 satellites, 101 satellites were foreign satellites, 95 alone from the US. So we did generate a lot of revenue out of these 101 satellites. So that's why for all these we see that we generate a lot of revenue. That's why it becomes a big source of revenue generation for India. So that's why, yes, this is a very very important point. Now comes some of the other points. So these are now all the economic points that we are looking from the perspective of nanosatellites, that this opens up the private sector, or opens up this sector for private participation. Now we see that there are a lot of startups coming up in India. There are a lot of startups that are running in India which are working in the sector of nanosatellites, or space sector, creating nanosatellites, building parts for satellites. So there are all these new companies, new startups which are coming in, and that's why private participation in this particular scenario also has been increasing in India with the help of these nanosatellites. And that's why if you go one step further, it also creates a lot of employment opportunities, so helps in employment generation. It helps in uh, employment generation. So, oh yes, you are correct, Srijit. It was PSLV C37 and not PSLV C34. Thank you for pointing it out. This was PSLV C37. Yes. So we see that all these things are also working, and today we see that's why there are setups that we have in India, setups like New Space India Limited or NSIL. Then we have In Space that is working in this sector, and we'll discuss about NSIL in space. And also we have the small satellite launch vehicle now, which is essentially meant for the small satellites, meant for these kind of satellites. So that's why we see that there are all these points that you can mention, and depending on how the question has been asked, you can pick and choose whatever points are needed. And that's why these kind of questions going forward can become important from mains perspective as well. So that's why all these points have to be taken into account, and you have to think of it. For example, if you take PSLV C51 and PSLV C52, where for the first time the the ISRO also announced that some of the parts that were used were made by private companies, not rather private companies by but other companies. So like Bharat Dynamics Limited was mentioned in that particular launch, which happened in, I think, February 2022. So they mentioned about it that this launch that we have done it with the help of some private players. Now what we see is that as soon as these are mentioned, these companies, they also saw a jump in their share prices as well. That Bharat Dynamics Limited, until the point that it was mentioned by ISRO, the share prices used to be around 200, 220, etc. Today the share prices of Bharat Dynamics Limited are beyond, I think, 1700, if I'm not wrong. So that's the kind of jump that the share prices have seen, because now people understand that this company is getting government jobs, getting the government projects. So hence it will also see a lot of growth probably in the coming years, and hence the share market also sees that rise. So that's why just remember all these points, so that if required you can use these points to your advantage, depending on what kind of question, in what sense the question has been asked. Then we have university or academic institution satellites, where these are satellites which are designed by people or students who are in colleges, in universities. So these students, along with their faculty, etc., they might design these satellites. And if these satellites are good enough, then these satellites will also be launched by ISRO. And ISRO does not charge, of course, for all these launches. So obviously, for a student, doing a private launch would not have been possible. So this is where they get the help from ISRO, and it also helps in fostering more interest in the minds of the students, because they will also see that, okay, if I do a good enough job, ISRO might do a launch for of launch of my satellite. So it also garners a lot of interest in the minds of the students. So that's why it becomes important, because growing further, they are the ones who would be the participants in the space sector. They may not join ISRO, but at least they will uh, contribute to the space sector in the country. So that's why it becomes very, very crucial, and all these uh, events and all these perspectives, they have to initiatives have to be understood well. So Swayam, Pratham, Kalam Sat, all these are examples of these kind of satellites. Read this question. There's one small mistake here. D had to be only, I mean, D had to be 1, 2, and 3, and C had to be only 3. I may have given the answer by doing this correction, but anyway, please mark your answers. Yeah, many launches can happen is also a point, but as we already discussed that they take less time is basically something that is related to the same thing, that is multiple launches are possible. Let me launch the poll for you. Please mark your answers. So 71% of you have marked the correct answer. Many of you, because I made this correction probably. So let me discuss this question with you. For the measurement or estimation of which of the following are satellite images or remote sensing data used? First is chlorophyll content in the vegetation of a specific location. Now, can we measure chlorophyll content? Yes, we can. And how do we do that? By measuring the intensity of green color. By measuring the intensity of green color, we can do the analysis of how much chlorophyll content is present in the vegetation of a specific location. So satellite images can help us in determining that, and that's why this point has a very important agricultural application. Because if, let's say, the nutrition is lacking in the agriculture of a place, then it might also mean that intensity of green color will be less, and then we can take measures so that we can feed the plants better or provide better fertilizers and nutrition. So that's why this is correct. Second is greenhouse gas emissions from rice paddies of a specific location. Now, from rice paddies, what is that greenhouse gas that is emitted? Can you tell me which greenhouse gas? Which greenhouse gas is emitted from rice paddies of a specific location? Methane. Perfect. So this is methane. So it is about doing the analysis of how much methane is present, how much methane is emitted, and that also can be done. Any gas that is being emitted, whether it is carbon dioxide, so satellite can tell you about carbon dioxide emissions. Satellites can tell you about methane emissions. So there are analysis that we can do. The spectrometric analysis can be done, and they can actually help you in determining how much of gases are being emitted. So this is also doable. Third is land surface temperatures of a specific location. Now, land surface temperature is associated with the measurement of infrared radiations, and even this is doable. We can find how much infrared radiations are being emitted. We can do the analysis, we can take the infrared pictures, and that will also help us in determining the land surface temperature, which also has an application in agriculture. So that's why all these 3 points are correct, and correct answer will be D, 1, 2 and 3. And this question specifically was asked in the context of a satellite that was launched in 2018. This was HISIS satellite. HISIS stands for Hyperspectral Imaging Satellite. So hyperspectral imaging satellite. That's why the name HISIS was given to this satellite. So this HISIS satellite was launched, and largely it had all the agricultural applications, and it could do all these things that are mentioned here in these three statements. So instead of asking directly what is HISIS satellite and what can HISIS satellite do, they have flipped the question, and they've simply asked whether satellite images or remote sensing data can give us an idea about all these things. So all these were actually applications of HISIS. So HISIS was launched in 2018, and this question was asked in 2019. So they basically have camouflaged a current affairs question as a general question. All right. So this is something that was asked in your paper. Now, Lagrange point is a big topic. Let me just start with this topic in the next class. Let's not start here. It's a very, very important topic. So we'll start with Lagrange points. We'll take all the remaining portions of space technology in the coming class, in the next class. That is on the next Saturday. Meanwhile, if you have any questions specific for me, please go back and revise. And if you have any questions, you can always write to me at rasesh.kumar at byju's.com. You can write to me at rasesh.kumar at byju's.com, and I'll try to help you as much as possible. So with that, let me end the session for today here. And please go back and please revise. There are a lot of things that we have discussed in yesterday's and today's class. It will need your week to complete everything and revise everything. So please do that, and please come back in the next class by doing it. So let me end the session here. If you have any questions, please let me know. I'll discuss that. Any textbook that we can prefer? No. As I told you, a lot of things that I've picked, they are not from any textbook. These are set of data that I've put, the concepts that I've compiled on the basis of what could be asked in the examination, and it's not only based on what has been asked in the examination. So that's why I wouldn't suggest a book. Please follow everything that we have been doing in the classroom, plus add current affairs to it as much as possible from all the daily Hindu analysis and all the various discussions that we do for you every day. Please do that. Leaderboard. Okay, let me show the leaderboard. This is the leaderboard for you. So two of you have given all the correct answers, Ramavat and Aniket. Many, many congratulations to you. And I'll send you my address, and please send me a small gift for getting all the answers correct. Others also, you have done very well. Congratulations to everyone. And for those of you who could not get the answers right, at least I hope that you learned from the explanations, and you can get them right the next time when you get something similar. Please share your UPSC CSC journey. The journey the journey ended more than 10 years back, and it was 2013 when I last wrote the examination. Went until qualified the mains examination once, but there was a big mistake that I did. More than what I did, what I should not have done is what matters. I changed my optional subject. Initially, my optional subject was mathematics, and I was very confident with mathematics. I also prepared with mathematics optional, but then I changed the optional to sociology because many of my uh, friends and colleagues, they were preparing with sociology, and there was a basic notion that sociology is a very easy option to take, and there were candidates who had competed with sociology optional in the previous years. So that was a notion developed, but I don't think sociology was the optional for me. It was just an option that I took because others were taking. So one mistake that I think that I should not have committed back then. Other things were going fine and was well prepared otherwise, I would say. Monthly magazines enough for current affairs or anything extra? See, my preference always would be the daily resources that we provide you, the daily Hindu analysis and the daily CNA that is provided to you. I would say that that's more important as a resource than the monthly magazines. If you are unable to follow these resources on a daily basis, then switch to monthly magazines. Otherwise, the preference should be given to the daily analysis that we do for you. Please upload the slides where you're unable to get them. I'll ask the team. I'll check with the team if there is any problem. Your explanations are clear and easy to understand. Thank you very much. Should we make notes on disadvantages of satellites? I don't think so. Uh, that you need to make any notes for disadvantages here, because largely we are concerned with, I mean, we are talking about the advantages. Yes, there are limitations, and we'll discuss about these limitations in the next class. For example, space debris is one limitation, so we'll talk about them as well. But disadvantage wise, wouldn't say that. What is the suggestion for us from your experience? See, my suggestion would be, don't be uh, a part of the herd. That if five people told you that this is what you need to do, please don't do that. You know better than others what suits you, what's good for you, and what's not, where you are strong and where you are weak. So follow that, always try to follow that instead of doing anything that goes against it. That will help you a lot in your preparation. And also backing yourself as much as possible. People like us, we did not, and I mean we did not also have the help. I mean, we're preparing at the time of the college, so maybe these things will help you. But backing yourself, revising, being constantly in touch with the studies, being constantly in touch with the practice that is needed for this examination is very very important. Look, more than anything, what works in this examination is perseverance. Having that faith and continuing with this preparation for as long as you can, and as long as it takes to complete your syllabus, revise and practice before going into the examination. The economics test series explanation video is available, but when we try to open it, it is showing error. Okay, fine. I'll talk to the team for it. But if you can also drop an email, that will also help us better. I understand all the things in the classroom, but test के time पे भूल जाता हूँ. Any suggestion? Happens to everyone. Happens to every one of us. Nothing new. It's just about how much you revise, and when you revise, how do you revise? I mean, for example, let's say one of the best ways to revise also is to close everything and try to recall everything that you have studied and think where are you missing. Many a times, what happens is that while revising, we don't revise, we memorize, and that also is a wrong strategy, because then you would only know what I have written in the slides, or what notes I have given you. If there is any variation in it, probably you're not able to answer. Like for example, when I said that geostationary satellites have 0 degree inclination, is what I said. The statement said that they lie in the plane of the equator. Both of these statements mean the same thing, just that they have completely changed the wordings while making that statement. So if you understood the meaning of 0 degree inclination, you would be able to answer it. If you had memorized 0 degree inclination, chances are you don't understand the other ways of writing the same statement. So that's why how you revise also is a very very important factor in determining uh, whether you're doing good or not. Region of cloud is nebula, not only clouds, but you can say clouds of dust and some of the ionized gases, like hydrogen, helium, even methane, or hydrogen sulfide, carbon dioxide. There are all these things that can be there. Has India successfully launched pico satellites? Yes, we have launched pico satellites, and there are private pico satellites also. Will be good if you share your number. It's very difficult for me to pick the phone, so it's better if I don't do that. It's almost impossible for me with how the day goes. I mean, tomorrow morning 6 a.m. I have a class, so 6 to 9:30 I'll have a class. Then after that, there's the work with the content team that I'll have to do, and then in the evening I also have an offline class in Bangalore. So you know how the day goes, that from 6 a.m. until 9 a.m. I'll be completely occupied, so it doesn't give me time. So it's better if you drop me an email. I'll at least have the time to answer you. Also some motivation as to what to do for 2024 prelims. Now 2024 prelims, you know that you are now left with almost 3 months of time. Now in 3 months of time, don't try to completely overhaul your preparation. What works here is, first of all, to solidify anything that you have studied. So you have to ensure that you revise and practice. The role of prelims test series also is very very important here, because that helps you revise and bind everything together. So prelims test series, uh, regular revisions, going through all the chapters which you are strong with first, all the subjects you are strong with, and not trying to do any experiments anymore. So all these things are very very important. Try to close the chapters, try to close the subjects. One of the most important mistakes that a lot of candidates commit is that you open a lot of things, you don't close them. Closing the subjects is very very important, that you go back, pick the subjects, revise them, practice them, and ensure that you have holistically covered them. Also add the current affairs of that subject while you are revising. So holistically closing the subject is very very important now. 2025 prelims suggestions, I would say that again the same thing, that one by one pick the subject, complete the subject, pick the subject, complete the subject, add the current affairs to it, practice on it, write as many answers as you can. And writing the answers is also very very crucial, because more than anything it's not about how many marks you get or how the evaluations have been done, but rather it helps you in revising, it helps you in consolidating everything that you have studied. Do you take classes in Hyderabad? Yes, I do. I mean, last year I've taken, this year also. Again, I'll go. I don't know when the classes are scheduled for me, but I'll be going to Hyderabad. Nanosatellite launch is with large satellites. Normally, yes, but not necessarily. We can actually launch nanosatellites independently also. Science Reporter magazine, where do we get? I mean, you can get it on their website, but it's paid subscription that they have. Uh, but some of the PDFs are also available. There are unofficial ways of getting it, which I can't tell you in the live class. CSAT relatives, because last year, especially maths was tough. Yes, last year's CSAT paper was one of the toughest papers that has come, I would say, in the last 10 years, perhaps. Uh, they should not have asked these kind of questions. I hope that they do not do that again this year, because when you have made a question paper a subject qualifying, then treat it as a qualifying paper and ask questions where you are only testing the qualifying nature of the paper. But unfortunately last year's paper was not such. It was a difficult paper. Now in that scenario, first thing is to see, I mean, just going back to the paper and see how much are you able to score. Let's say in a tough paper like the 2023 CSAT, if you are able to get an 80 or a 90, then you are well placed. Then I wouldn't say that you have to be worried about that paper. But if you are scoring in the 40s and the 50s, or let's say even less than 40 in that paper, then you have to mark the areas. What are the areas where you are not able to do good, and attend the CSAT classes, revise them, uh, practice as much as possible, and that will be required so that you can reach a level of 90 to 100. If you are able to do that, qualifying marks is anyway more than 66, you will be able to do that easily. Yes, unpredictable public service examination. Now, more than unpredictability, last year was a problem in a very different way, because last year's paper, I would say that more than it being a tough paper, a difficult paper, it was a vague paper. The kinds of questions that they asked, not only in CSAT but rather even in GS, it makes no sense to ask those questions. I mean, I'm being blunt here. Maybe I should not, but it doesn't make sense to ask even those kind of questions. A couple of questions even from science and technology that came, although I had taught those questions, I had taught that in as a part of the classroom or as a part of current affairs, but I never expected those questions to come. Those were just information. There are random information that I keep giving you in the classroom. So those random information, they ask questions from there. Never expected them to do that, but they did it. Not only in science, they did it in every other subject as well. Right. So let's end the session here. If you have any questions, you can always write to me here, or you can also write to the support emails, that is islive@byju's.com or targetis@byju's.com. So let's end the session here. Let's meet back on the coming Saturday. Meanwhile, please go back and revise everything that we have discussed in the last 2 days. Thank you very much.